All right, hello. I'm gonna have to load this. Let's light up the place a bit. Right. Going to be waiting for people to join, I guess. I hope this recording's not going to be of me and only me. Well, if people do decide to join at some point, I'll just let them in. Until then, I'm going to start. I set up a neat little PowerPoint over here, which of course contains the welcoming message. So today's training session is going to cover a lesson plan, some general information on the whole platform, some tips on teaching, and of course a Q&A section, which provided someone else joins, we're going to also be able to host. Currently, we're going to be going over the lesson plan, right? So the first lesson of the whole plan is an introduction lesson. In this lesson, we'll be covering basic aspects of C++ language, like syntax, hello world, why pick it over others, and what can be done with it. In the second class, we're going to have input, variables, and data types. Right, so after covering that, we'll also present how to take console input and actually work with variables we're given or we declare. In the third class, we're going to go for operators in mathematics and C++, where we'll be covering operators, classifying them, for example, arithmetic operators or other kinds, and giving examples as to how they work. This is also the first encounter with pointers, as we're also going to be introducing the dereferentiating operator. But it's going to be a brief encounter, so students shouldn't be afraid of this, neither should teachers. The fourth class will cover Booleans and conditionals, with instructions like if, switch, and explaining the basic use of variables and their importance in stuff like, let's say, we want to have a map, a problem that's based on a map, and we need to know if we visited an island, for example, like a fill problem or a Lee's algorithm problem. We're going to also need Booleans for that to know where we checked and where we didn't. Now, in the fifth chapter, we're going to go over loops, where it will be a brief introduction to the basic kinds of loops, like the for loop, the while loop, the do while, without the complications and their particular variants. But we will build upon them on the level 2 curriculum. For example, using the fors with iterators instead of just declaring variables and going statement 1, statement 2, statement 3. The sixth chapter is going to be arrays and pointers, and this one is quite theoretically heavy, as in it's very written. A lot of the explanations are written, and there's not much of a demo. The thing is that that material is intended to be more of a guide for the teacher. So the teacher is basically supposed to present said material while having an actual example. And I didn't include an actual example in this. I designed the curriculum with Shreyas, if I'm pronouncing his name right. So we didn't include said example in arrays and pointers because everyone has a different way of explaining it and teaching it. And students also have different ways of understanding it. So we didn't want to constrain them into just one way, like where you understand or you don't. We don't want that kind of constraint. So that's why we left that up to the teacher. Then in chapter 7, we're going to also have functions and recursive functions. It's going to be quite a brief introduction because functions are rather intuitive. But again, it's another thing that can be covered differently depending from teacher to teacher. In not too long, I will also showcase the method I prefer for explaining how recursive functions work. But of course, this example should just be taken as a general guideline. If you find any other methods, you have a teacher. And of course, in the 8th chapter, we're quote unquote testing the students in an assisted and monitored environment where you're basically going to be solving some problems with your students, or if your students are good enough, you can let them solve the problems, review their code, and basically guide them through it. So to demonstrate a bit, we're going to be going on the platform, which I conveniently have open here. This is not the final way the course should look, but it's definitely what most of us will be working with until we also get to level 2. So the first class I mentioned that can be done differently is arrays and pointers. So we're going to be going over the material for arrays and pointers. It's uploaded in Google Docs, and you'll see why I said that it's very theory heavy. There's just a lot of written elements into it. It's a lot of reading to do. You've also got some sample array problems, which can be used to demonstrate that with an IDE. I also recommend teaching this course just full with the IDE. As you can see, we've got pointers, the explanation like adding an asterisk, so how you declare pointers. This is more for the teacher to see. What the students should see is pointers in action. Of course, for now, we've got no homework because that tab is an extra one. Suppose any problems remain from array problems, that can also be used for homework. Right, so this would be why I said that pointers are very theory heavy, and so are arrays. But let's get back into it. So the next chapter on the PowerPoint is functions, and of course recursive functions at that. So my way, or at least how I present functions and recursive functions from my experience, is just quote unquote code recycling, as in we can fence a bit of code somewhere. Like take this bit and say, right, you are in this fence right here. The other function has its own fence. So functions make things a lot easier to track down, like bugs and stuff. Find it far easier. So you can correct said bugs. At least that's how I like to introduce them. And then we've got how to declare functions, which I don't think it's that, I don't think it shouldn't be explained that thoroughly. It's quite intuitive while we're at it. But then we get recursive functions. And the way I present recursive functions is I either encourage students to get their own, I didn't mean to open Notepad, I wanted to open Paint. So I encourage students to usually get their own notebook or something which they can draw on, so they can make the schematic and try to go through it with me. For example, we're going to think of a recursive function. The most simple recursive function would be the greatest common divisor, right? Okay, maybe this may be a bit too advanced. So suppose the students are just looking at you, staring blankly, right? You're getting silence when trying to introduce recursive functions. I suggest you just pull up Paint and start drawing this. Right, doesn't look like much, does it? It's like an open box. But as some of you may know, you might actually be familiar with this schematic. This is how we're going to represent the stack, right? So, you know, the stack memory type, where basically each little iteration, quote unquote, of the function is represented on a different place in the stack, with the most recent being up top. Think about it like dishes. For example, you overlap dishes, right? You've got dish 1, dish 2, dish 3, dish 4. You need to take out the 3 dishes above dish 1 if you want access to the first dish. And then you can put them back, but that's a different story. So that's how I like to explain the concept of stack memory. Now that we have the general idea of stack memory, we're going to go into how a recursive function goes in a stack. So with usual iterative functions, or not even functions, let's take a loop, for example, right? We're going to have a while loop. It would greatly help if your drawing skills were better than mine. So we're going to have a while loop. It's got iteration 1. It does this, something, iteration 2, iteration 3, so on and so forth. It keeps going and adding more iterations, right? Well, now let's convert this. How would we go about approaching this? And this is a question you can ask students. I heavily encourage interaction with students in this course, because if you're just laying out theory, they're just going to stare at you. Trust me, I've had it happen to me. It's not a pleasant feeling. So try to interact with them as much as you can, even give names. For example, say student something. What do you think would happen? Doesn't matter if their answers are wrong. You're going to help them, you're going to correct them, and they're going to learn from it. That's the whole point of teaching. So now we've got the while, right? We can compare this while loop to like a less iterative way, a recursion, right? So this box right here is going to be the initial function call, right? So this can either be named F1, which is the equivalent to the first iteration. And this first iteration is going to call itself back and say, all right, but I need another box myself, F1.2, for example, or F2 actually. And it's going to call itself again in another box. And now, if we take these boxes and reverse them, so for example, reading them like this, we're going to notice that when reading them from function 3 to function 1, we're going to be getting this stack. So level, well, this is going to be level 2, but you can, for the sake of convenience, you can call it level 3. You're going to correct that later. You know that in programming, we start from 0. But for the sake of the students' understanding, you're going to introduce them with 3, 2, 1. So now we know that whenever function 3 finishes, whatever it has to do, function 3 will go back to wherever it was called. So for example, let's say function 3 was called in this line and it's called this line to process, right? Well, function 3 is done for. We're back to function 2, and when function 2 ends, of course, it's going to go back to function 1. It's like removing element 3. I don't know, we're going to plop it somewhere here. Now this is our element 3, and there is nothing left here. And we're going to have access to element 2. So now, suppose you were the student. I think you may have clearly understood the whole idea of stacking and how recursive functions work and why they are so able to go back. Because this is level 1, we're not going to be going in depth as to how they actually work. But students need to get a grasp of this to properly use them. Right, so now that we've got access to level 2, we're going to go to level 1, and then we're going to empty the stack when the function has finished. This is my approach. All right, my approach does not have to be the same as yours. As I keep saying, every teacher has their unique style. But I found that this approach to explaining stacks and recursive functions is the most effective of them. All right, so now I'm just going to close this paint. And I'll go back to the site, which will also go a bit deeper into in a bit. Of course, the last chapter, practice problems, right? It's meant to be a safe environment. You know, like before an evaluation or something, students are meant to go through this quote unquote training environment. And you'll notice they are linked to other places. For example, this one links me to Code Forces, right? Of course, this may not be the best political context to use this site, but the problem in itself is great and honestly worth it. So we've got the elephant problem, right? What we're doing here is encouraging students to go on and basically work. We've also got a USACO problem. As you can see, this is a challenge problem. So how this is structured is like this. You've got these problems. They're going up in difficulty. These are all recommended problems. You know your students best, so you may choose other problems. But this is what we would recommend as in something that can progressively raise the difficulty over the course of the final hour, right? And the whole idea of this part is that you've got two options. The first option is opening up the IDE on your end, right? Just firing up Visual Studio or code blocks, firing up whatever, honestly. You can fire up the IDE and start solving the problem, which in some cases may be good. For example, if you know that your students are shy, I found that this version is way better. Why is that? Well, shy students, usually like they're going to solve the problem on their own, right? I was a shy student myself. I know that's what I used to do. So they're going to solve the problem on themselves, but they're not going to have the confidence necessary to tell you that, hey, look, this is my solution. Could we look over it? So instead of that, the other variant is just firing up the IDE on your computer and starting to solve the problem, but don't solve it yourself, all right? We're not testing you. That's why you had your evaluation. What we're actually doing here is enabling you to give students a confidence boost. To add this, right? So why is this a confidence boost? When students see you solving a problem and sometimes even faking struggling with it, you're going to obviously ask for their help. And you're going to go, student X, what do you think about this? How could we proceed? So this needs to be a very interactive experience. What you need to do is just, in the worst case scenario, and I repeat, that's a worst case. For example, say a student makes a mistake, right? They may be able to realize that on their own. So first of all, tell the students a question like, are you sure this is the solution if they say something wrong? Or of course, congratulate them. As you know, students must also be rewarded, at least mentally, if not compensated. So you need to take on a more supportive role, right? So let's say, I don't know, some student forgets how to read a variable, right? So we're going to declare a variable X here, and they're going to forget how to do that. Right, so what could they do in this situation? So you're going to go ahead and ask the class, hey class, what could we do to read this? And some of them are probably going to suggest the correct choice because it's basic input, right? But what if they don't? What if, I don't know, for example, they say something like, well, they shouldn't be able to say that at the end of the curriculum. But suppose it happens, right? This is just a minor example. You're going to go ahead and say, are you sure about that? And if they say yes, you're going to actually run the program. And when you run the program, they'll get to see the errors from the compiler itself. They'll think again. And if for the second time they come up with the wrong answer, I found that asking the class again gets the shy students to speak up, because they're going to be like, oh, look, hey, he didn't know, but I feel like I know. The teacher wasn't harsh on them. The teacher just asked someone else, and the shy students are going to speak up. I found this technique very efficient, actually. So they speak up and they say, well, this is how you would do it. Is that correct? If they're correct, of course, you're going to tell them, yeah, exactly. That's correct. Thank you very much. Could you continue? Because usually when a shy student corrects something, right, they correct an issue in the code, they also want to continue. They have other ideas. They have a vague idea of where the problem is going. It's not just shy students, students in general, but I'm just talking about this particular kind of student because these are probably the hardest to deal with from what I've taught. So you're going to let them continue. And this process, I don't know if it should be repeated for every line. I don't think actually it should be repeated for the same line. It really depends on the class, and that's your job as a teacher, adjusting to your class. For example, my class right now is right about 0. Nobody's here, but someone is here watching the recording, right? So you need to be mindful of that. For example, I love doing 4-4 breaks as I'm doing now, but that's because I'm just giving an example of how to interact with students, right? And that's another thing. If your students feel absent, first of all, you need to question yourself, what have I not done? How have I lost them? Because usually students get lost because one of two things. One, they find the class boring because it's too simple, or two, they didn't understand anything. Usually, you should try and go back, like, did everyone understand what we just did here? For example, we're going to be building a for loop, right? Something I++. This is the most basic for loop of them all. But some students may not know that you can declare a variable in the for, right? Or they may have forgotten. It happens. So you can ask, like, hey class, did you understand what we just did here? And of course, they will almost never speak up. They'll just go, yeah, of course we understood. Usually, you can take two approaches here. You can either be a bit pushier, like, are you sure you probably understood? Or you can just continue. And when you get to the next loop, for example, let's say we need another for loop, you're going to ask one of the students to complete it. And how is this efficient for those that didn't actually understand? Well, the moment they see that another student understood it, the student themselves are going to be a bit more motivated to try and understand it when the other student is explaining, right? So for example, if they weren't motivated to listen to you, they're going to be pretty motivated to listen to their peers. So those are some of my tips and tricks on how to make sure that students understand what you're working with. For example, this problem, right? So this is the approach where you've got some shy students, some students that don't want to speak up. All right, but let's say you've got some students that just really love working by themselves. They don't want you messing around and fiddling with their code. They want complete control, because at the end of the day, they're here to learn, and we should be very proud of them and encourage them to do things on their own. What do you do then? Well, in that case, I recommend you just give the problem to the students, give them enough time to read through it, ask, hey, are you done reading? Do you need a summary, an explanation, or something like that? And of course, if they request it, you are going to explain the problem in a bit of a simpler way. because some problems tend to have really horrible phrasing. Let's open this link and see if I can find an example. Oh, wow. Right, this problem doesn't have bad phrasing. Let's say, I think I also saw one. Simple enough. Anyway, let's go back to code forces. Right, so this, you've got the first section where you've got kind of the story behind the problem. Then you've got the second section, which actually covers the input data, then the output data. Suppose someone doesn't understand, you can first try and summarize the input and output of it. I find that this usually works. Like the first line requires this, the coordinates to the elephant's friend's house. The output is the minimum number of steps the elephant needs to take, right? So just summarizing it that way, instead of the elephant decided to visit a friend, you can lose students. Like you're going to lose their interest if the whole questions are very, very long. So that's why I said that you can summarize it if you see fit, of course. If the students understood, then it's all right. So that would be my idea on how to explain problems. Going back to what happens if the students themselves want to take the whole challenge upon them. Well, you're going to let them take the challenge. All right, everybody loves a good challenge, even I do. And say, I don't know, from time to time, ask like, hey, is anyone stuck? That's an idea. Do you need guidance? That's another idea. And then just, you can ask for the solutions and go over them with the students. For example, student X sends you the solution. You're going to tell everyone to take a break, and you're all going to watch student X's solution as either they share it or you share it on your screen. And you try to go through the code, have them explain what it does. Because keep in mind, while we are training them for competitions, we're also training them for actually learning the language itself. So they need to know what everything does at a given point for their sake. And they also need to learn how to express themselves and explain it. For example, hashtag include IOStream, right? Some people may ask, what's this line? And they need to be able to explain that, oh, look, this line includes. If the person is more technologically inclined, they need to know that, well, this line includes the library of IOStream, which handles input and output with streams. Or of course, if the person is less technologically inclined, they're just going to say, well, this handles input and output. I find that very, very important for the future of the students, right? Because the future doesn't start or stop at competitions, though we heavily encourage them. We also need to know how to work with the code, how to present it to a client, for example. In any case, there is also one more situation, right? No class is going to be a perfect shy class or very outgoing and curious class, right? No class is just going to have only one kind of a student. Classes are going to have many types of students. So what's the final approach then? Well, I think the final and best approach to these coding problems, because remember, we're in an assisted environment, is this. You're going to go ahead and solve the problem by asking students, hey, what do you think goes here? Student X, student Y. But you're also going to let them work on their own code. So for example, they have their own code somewhere on their monitor, and suddenly you call them like, hey, could you please help me complete this, provided you got this far? And I think that's one of the most efficient ways, because the students are all going to be paying attention like, hey, look, a fellow student is speaking. What could they be speaking about? What if they're wrong? What if they're right? The mind of a student is quite a complicated one, as you might remember from when you were a student. So all in all, I think these are my pieces of wisdom. So to summarize, what we want to do is in the 8th chapter, which is basically the final one, we want to give students an assisted environment where they can solve problems, right? So you're going to also be solving it along with them, but you're not going to be the one thinking, they are. If that makes any sense. Then, going back, you need to make sure that you try to explain things as I gave the example. So don't be afraid to be creative. Use diagrams, use Microsoft Paint if you've got nothing better. But try to draw and try to use multiple colors, because multiple colors help students differentiate stuff. So for example, you saw how I used multiple colors for my layers in the stack, right? That's going to catch the eye of the student. We're going to be more attentive to that part. And another tip, and that's probably the final tip I have in this summarization of what I rambled about for the past couple of minutes, is just show the student what they can do, right? You're programming. They need to see it working. Code is never convincing enough. People want to see things work. They want to see what they create come to life. So try to compile as often as possible. For example, you make a little change. Let's say you say cout X, compile and show them the result. Like, hey, look, we did not add this just to get a good laugh out of it or to waste some time. We added this because its consequences are that. So try to present a cause effect whenever you add something new to the code. Of course, it's not always going to be possible, like adding a loop, right? It's not always going to have a visible effect until the end result. But if you can do it often. Right, so let's get back to the PowerPoint presentation itself. Well, we're not done yet. This would be the final slide, right? Seeing as there is nobody here, which, by the way, I would like to apologize for because it's been my fault. I could not connect to the Zoom due to a human error. I could not connect to the Zoom account until like 20 minutes past the time we were supposed to start the meeting. So I'm very sorry for that, right? But if you have any questions, right, you can reach me on Discord or at the Bitwise hashtag 7472 I left there. And of course, for other general questions, we also have the training session 5, which covers aspects like paying, scheduling, vacation, stuff like that. That's why we have that video. It's linked here. I don't think we get a chat history, but in case we do get a chat history, let me post it real quick on the Zoom chat. Not here, of course. Let's see, chat. So I left that there. All right. That's about all I can teach you. I don't think I have any more wisdom to share on this. And due to the Q&A section not existing, the only thing I can do is ask myself some questions. So, for example, let's ask some introductory questions, right? I joined Go Learning like a year ago, right? I was honestly looking for a summer job as a high school student. And I found that I really loved programming. So I went with this combination of I want to make money, I want to speak English, and I like programming. So Go Learning had their remote jobs, which were very convenient for me. So that's why I ended up joining them. And I don't regret it one bit, right? The staff is very friendly, very understanding of me, especially, and very patient. I cannot stress this enough. The work environment is great. All right. And I really hope you enjoy working with us. Another question would be how old I am. And well, I just finished my finals and I'm going to college admissions. But remember, I joined last year, so this should be a great indicator that as long as you're good, it's very accessible, right? And of course, what's this about AGO learning? What's our whole goal, purpose? We're really trying to spread the whole idea of teens teaching kids, right? People here aren't too old, and those that are very cool and young, very fresh in the head. So we always try to come up with fresh ideas. That's the whole idea of this, because we're more closely related. We are more likely to understand how students work, because in most cases, we're students ourselves. So that's the whole massive goal of AGO learning. As for any other possible questions, I don't know. You have my Discord right here. Feel free to shoot me up a message at any time. Other than that, I think this concludes today's training session. While we've cut it short and I've made it fast, that was because I was very late. So we kind of fast-tracked through everything. Again, I'm sorry for the people that tried to attend and then just didn't see me join. I thank you very much for your time and attention. And I hope to see you teaching soon enough with us.